I've made this experimental heat susceptor for microwave sintering.
You can see there's some vitrification. This was a foam piece which I densified. This was put through a kiln cycle.
Graphite was selectively infused to the raised regions on the top. This will act as the susceptor, or heat collector, for the microwave. So an internet friend had sent me some of these, which are little tiny, I believe if I'm not mistaken, either 17.4 or 316L testing bars. I think binder jet, if I'm not mistaken, but he wasn't exactly sure, or I might have just forgot. I think I kind of just want to see what happens if I zap this thing at nuclear temperatures and just see what happens. It's been a while since I've kind of run through some of the basics. This is just a crucible. I make these here. I'm going to layer some ballast material, which is an AO203, and some other additives to that I kind of mix in to just get the properties that I like. And that's going to support the piece that I'm going to put in there, which is just that tiny little test bar. I'm going to take the Susceptor prototype, place it on top, and of course the part's going to be buried with another layer of ballast, which is going to cover. The Susceptor part's going to be on top, resting a little bit, facing Susceptor face down. You never want to do this sort of stuff without ventilation. I have ventilation here, ventilation over there, ventilation over here, carbon layer, you name it. The part is tamped down and the Susceptor is placed on top. Here I'm going through the cycle. It's going through a gradual ramp up, followed by an immediate high temperature ramp. Alright, well, things have probably cooled down enough. Well, nothing exploded. We seem to have a little bit of shrinkage area here around the ballast. It's still noticeably warm. Tapping on that top seems okay. It's probably about 400 to 500 degrees. This is the testing bar after I've pulled it out of the crucible, followed by the green part comparison. Since I showed that, I'm not going to call it sintered yet, since I don't really know what the properties are of that. But the difference between the post-cycle Susceptor, you can kind of tell that part of this here, which is interesting, definitely is a different, not only texture, but color. Now it's time to examine the properties of this testing bar. In total, this was only sintered for about 30 to 40 minutes. With visible inspection, I can see some flaky, shiny looking specks, enhanced with light scraping. Visibly, this is promising, but to make sure, I need to try to snap this. And I was just going to try to, snap it with my fingers. I can't. If I can snap one of these green ones. Different look to them, you can see. Green and post microwave zapping. Let's see if I can snap this. I don't know. Never tried. Oh yeah. So here's the difference. That snapped without any problem. So that's kind of interesting. I don't know, maybe I sintered this thing. I got this one here, and I'm going to try to snap. There we go. That definitely took some force with these. I could not break it by my hands. Things seemed pretty promising at this point, and although it did snap, I wasn't intending to actually sinter this metal. I went into this testing an experimental Susceptor. After the promising results of the first sinter, I did follow up with a second center cycle. This is a different sample bar, and I increased the time from 30 to 40 minutes to about 1 hour in the microwave. This seemed to have dramatically increased the density and dramatically increased the surface finish to look quite shiny, as you can see. There were some cracking, which will be evident on the snap test later on, but the parts that do not have the cracking are incredibly strong and noticeably are of better quality. From there, I wanted to measure continuity, which it does seem to pass a current. However, there is a bit more resistance, most likely due to a not complete center, which that's my suspicion at this point. So from here, I went to the snap test. Let me put this here. Well, but it survived a concrete floor drop, so that's good. Here's a comparison towards the finish. There is some metallic sheen a little bit on this piece here, but this is by far just much more contiguous to see what's on the inside. I want to note how easy this was to snap right along that crack that I called out earlier, but as you'll see, it's not so easy on the other sections. Oh, that one's a good bit stronger. Actually, I don't know if I can snap that. Oh, okay. I find it very neat that without much effort, I can at least partially center, steel. This definitely looks better than the sample from yesterday. Proves to me that I think it does need a little bit longer heat soak at the top, but again, this was a very low effort. I wanted to summarize and join these two together. These were on 2 different days, and just wanted to say that going into this, I didn't really expect to end up with a result of partially centering these test bars. Again, 316L or 17.4, I think it's 316L, has a very high temperature requirement, and these were done with an experimental Susceptor that I also didn't know how it would hold up to the abuse of heat cycling, which seemed to do okay. I think I have some improvements. I would like to try this again with a more formal setup. And anyway, it's just exciting to see what can be done here with garage level equipment. So, cheers.